Frida Frost is, as it says here, the Chief Operating Officer of PowerLabDK, which is a Danish technical university. I actually met Frida recently virtually, but I feel like we know each other because we've been working not only in the same circles, but we've been working, I've visited her lab many times. So I was, 10 years ago, I started working with Dresden, which is working at PowerLabDK. And so I've been there and I've been seeing their work. It's amazing. She was appointed there in 2017. PowerLab is an experimental platform for electric power and energy, and is a national green lab under the Danish Energy Agency. So they do a lot of proving out of technologies. They have lots of different applied projects there. It's really awesome. Frida earned her MSc in energy from the Technical University of Denmark, DTU, and she continued her education at Copenhagen Business School and also in INSEAD at France. Now, she has a great combination of sort of like technical and engineering background and business policy. So she's actually very well, I'd say, positioned to talk about green transition the smart way, which is what she's going to talk about today. She's 25 years experience in energy, climate, environmental policy, and the societal development in Denmark and in international issues. She's a former president and chair of the Danish Society of Engineers. She wants to strengthen the knowledge and focus on STEM and really engineer for the future, which is a collaboration between university and private sector. I think Denmark's very good at that. She specializes in disruption. I hope she doesn't disrupt our workshop too much, but at least a little bit. And she really looks at technical innovation, the green transition. I really have always been impressed with working with the Danish team, which we've worked in the past, about looking at this green transition. I mean, Denmark has done a pretty amazing job, although they have some hurdles and they've seen hurdles, but I think they've done a great job. So I'm really looking forward to listening to Frida today. Frida, thank you for coming today, and you're very welcome.
Thank you so much for a very long introduction. I think I would like to, well, first of all, I would like to just thank you for having all this virtual conference and with so many people from so many places, interesting in the same topics. It's really amazing. I'm been very looking forward to participate, and also I would have loved to be there in physical, but that must be in a later year. I will try to share my screen, and please tell me if it will pop up. Can you see something now?
Yes.
Yes. And do you see all this? This one now is the full screen.
Looks great.
Looks great. Super. Okay. Just very short about what I would like to let you in on. Yes, I would love to talk about my lab, but I have prepared a little more about where Denmark where are we right now in this green transition, but also what can we do as a lab and as a university for helping the society to develop into this in a smooth way to do this green transition. It's a very, some will say very expensive way, and others would say, oh, it's a way of growing. You can actually make money out of being the first mover on this one. So I'll give you some thoughts about how it is to be a Dane in this green transition. And of course, we would like to do it the smart way. And with the smart way, we mean using all the digital tools also for doing this. But first of all, maybe you don't know where Denmark is, or at least none of us has been traveling for the last 2 years. So let's travel. Let's go to Europe first of all. And I don't know, it's a morning for you guys, but for me, I'm going out for the dinner at a restaurant in an hour from here with my family. We actually have a vacation week this autumn week of vacation. So let's be in the touristy mode for just a short while. So now you see Europe, and in the middle of Europe, there's a very small country, and that is Denmark. And if I expand Europe a bit, I have made a circle around Denmark, and you can see all the bigger countries as France and Spain and Germany, but Denmark is actually a very small land with a very high impact. we would like to say. And if you look at the right picture here, you can see a lot of green, and that we are very farming geographical area, and only you can see here in Norway, we have mountains, and that they have a lot of hydro plants. And we have all the wind coming in from the North Sea. So we have all this wind power, and the combination of having hydro plants and also the wind that actually give us some opportunities to be very renewable. I'll come back to that. It's just, and then you can see it's with the Alps and more mountains down here, but it's very flat. It's very windy in Denmark. So what is Denmark known for? I think you might have heard about Vikings. So at least we're known for getting into other countries and steal all their stuff. Maybe not that good thing to be known for. But another thing is the food. Just put up some exotic fruit. Maybe it's not, but you can have if you're arriving in Copenhagen airport, you can actually buy this hot dog. It's a sausage within a bread. It's very Danish. A traditional thing to eat. It's out in the streets too. And also I think you all have heard about the Little Mermaid, which is sitting out in the water, being maybe sad or just thoughtful. And then we have the Danish pastry and open-faced sandwiches, which is actually dark bread with some meat or something on top. But it's yeah, I mean, you're all doing sandwiches, which is a bread on bread and something in between. We just have this open-faced sandwiches. But also we are known for Lego bricks and Danish design. I've put a picture of furnitures here, but it's also we're very known for big, great architecture of buildings. So this is just an appetizer for what if you would come here as a tourist, you might see or taste some of this. Next slide. Why is it not? Oh, this one. And also we're known for our energy sector, and of course for the wind technology. Just an overview of Denmark. We have a lot of energy production by the wind technology, and also some wind offshore farms just outside the shore of Denmark on the west coast, but also on the east coast. And actually, just to have an idea of how much we usually can actually cover a lot of our consumption within the power sector with the electricity, and when we can't, we will import some from Norway, from the hydro plants. But sometimes we also generate more than what we can use, and then we actually export it to Germany or back to Norway or to Sweden. But also maybe one interesting thing is that 6 out of 10 Danish households are supplied with the district heating, and that's very expanded in every village, every city in Denmark, and a little more than 60% of that are actually generated from renewables. So just to have an idea of how does it we look like if you look at it at the energy side. And also a little about the history. We had a guy called Paul Lacour. It sounds French, but he was actually Danish, and he invented some technical issue within the wind turbine, so that it can actually produce and make electricity in a way that we would like it, back in 1891. And then you can see a very small wind turbine from the 80s. Typical was a smaller one, and then we have been doing a great giant jump with the technology within the wind turbine sector from the 80s and until now, for the last 40 years. And the first offshore wind turbine came up in 1991 in Vindeby. That's very close to shore and not that out in the North Sea in 91. And then now, more or less 30 years later, we are projecting the largest wind turbine farm in the world, made by Danish wind turbine company in 22. That will be placed out in the North Sea. And if you look at the sizes of the wind turbines, it's just giants. It's really big wind turbines today. So also another picture of how Denmark has developed. If you just look back 30 years, we have these very centralized power plants, and some of them also fueled by coal. And if you look at the picture on the right and see all the dots or spots on the map, it's very decentralized today. And the blue ones are wind turbines onshore, and you can see a lot at the Jutland here at the land, but also close to all the windy places. But then you can also see the orange dots. It's a lot of local combined heat and power plants that just arrived during this period because of a policy that said we would not be based on centralized coal-based power plants. We will have this more renewable in our system. And we still have a few central power stations, but we're not relying on them as much. And then we have Bornholm. I'll come back to this very important island, Bornholm, later on. And this is one it's a sample of Denmark, you could say. So it's a very nice test island also. So I'll come back. It's part of our lab. That's why I'm mentioning it now. Okay, so here are some Danish energy goals. And in 2018, we had we wanted to be complete out of all investigation and drilling for oil and gas. That has been an industry for Denmark for years and decades. We also have had a lot of income of money for the national economy, but we shut down and had to find other sources of income. And then by last year, the 50% of the energy system should be based on wind energy, and I think we exceeded that. And in 2030, 50% should be of all the energy sector should be based on renewable energy, and we should have this reach this 70% CO2 reduction according to our baseline, and coal should be completely phased out. And then we have the goal for 2050, where it should be 100% renewable, inclusive transport and industry. And just to let you know that when we have been doing research and testing things and working with industry, we have these two policy goals, and I think that we struggle a bit with. There's one strategy for reaching the goals for 2030, but there's also some long-term strategy and decisions to take to reach the goals for 2050, and maybe we should go on both legs, but that's a discussion right now. If we look into Copenhagen, this is a very nice picture. A lot of people are biking. Also, every municipality or bigger city in Denmark has their own goals for what to achieve during different years. So for example, Copenhagen want to be the first CO2 neutral capital in 4 years from now. So that's a very high ambition to reach that. And then this is just about what is Denmark related and where are we right now within the energy sector. And then we will look at the DTU, which is the Technical University of Denmark, and PowerLab, which is the lab that me and a lot of great people are running at DTU. What are we motivated by, and what are we looking into? What do we need to deliver to the society and to create the new solutions with the industry. For example, past it was about renewable energy production, and it was all about the direct technology for production of energy. And we look at this as the easy part. The future will be much more demanding, because if we are relying 100% or close to 100% of renewables, you can't rely on it. When will it blow? When will it not? Will the sun be shining? If it's not? And what about storage? And how about resilience? How could we have a stabilized system? And how should the balance be between power and heat and gas and all this? So we need to look into how to do this in a smart way, but also in a way that we will not just invest in bigger grids, just to spend our money in a smart way and optimize it across the different sectors. That's what we're looking into. And I think you just mentioned an exponential curve in the beginning, George or Kurt. But actually, I think we are in the middle of an exponential curve with looking into a totally new energy reality. We are looking into so many different technologies developing right now, and that will be the electrification of our energy sector in general. And would that be the backbone? We could ask that question. I think a lot of people would say yes. But there are also some in the district heating area that would say, oh, the district heating would be the background. But at least that is what's going on globally. Then we have also the digitalization and data, and we can handle with IoT what is going on. We know a lot more than we did just 10 years ago. But how to deal with it, how that being function, and how to rely on that. And then also solutions are getting more consumer centric. Also, we have the production out at the consumers, not only from big central plants, but and then that also gives some that craves something of the grid, because now you are out with the thin grid and actually putting some production back, and how to deal with that. And then all the wind turbines, they're getting larger and bigger, and pulled in farms, and that also give a bulk back into the system. And then we have all these distributed energy technologies out at the consumer places. We have automation and digital AI solutions within the grids. And then also we have seen new markets, and markets that are not even open yet. And that will be markets for flexibility. We have this Nordic Børs where we exchange the pricing of power. But I think we will look into new markets with where the flexibility of giving a balance to the system will be an asset, and then that will create a new market for less than 1 second balance, or maybe a minute balance, how the storage in different levels, and how to be a service to a balanced grid. I think that will create a lot of new business opportunities and markets. And then we have all the conversion, how to go from one energy form to another, and then batteries are getting cheaper and cheaper and bigger. And we also have the smart homes. As you said, you had so many data in all your buildings. That is new, and that is coming. And how will we use and optimize all that? So I think we are in the middle of something very interesting right now. What we have been looking into right now is energy islands, and that will be decided from the national politicians to construct 2 new energy islands in Denmark, one in the North Sea and one in Østersøen, on the other side of Denmark, between Poland, Germany, and Sweden. And then we will look into this power to X, where this big X, we're all looking at that, and sector coupling between the energy forms, and then also automation and AI. And sorry, this is a slide in Danish, but I have to mention this because at DTU, I think we like to say that we have 6,000 faculty. 1,000 of those work within energy. So it's very cross. We have 19 departments, and I think 10 of those were joined together in this strategy work we did during 1 year to combine all the competences from different departments in creating and actually the answer from our university to how to reach the goal for 2030. How are we going to do this? And this is a general model. What you see on the top here is all the sources. It's wind and solar, biomass, fossil fuels, and actually also atomic, what do you call that? Nuclear energy. We don't have that in Denmark, but it is a source for many people and countries. And then at the bottom here, we have all the services that it's transport, it's buildings for heat and electricity, and also industrial processes, farming and data centers, and then water treatment. That's actually some of the main consumers. And then this is not a black box, but it's a blue box called the system. And then you could put both the power grid and production and storage in this box. You could put thermal energy in this. You could put fluid fuel into this, and you could put gas also for heat supply. And then you should combine and optimize all this. And then what is important is how these errors also go back into the system, back into this blue system box, because they can also be providing a service and helping with the balance of the grid. So I really think we did a very great job also for suggesting how to kind of a roadmap for how to reach the goals for 2030. And then the question is, what should we do for 2050? And shouldn't we start right away with that too? So DTU, we have 3 strategy aims, and that is to be supporting technology for people and society. And that's why we are spending a lot of resources also to talk to the politicians and give them access and have a lot of visits. We have had so many visitors through PowerLab from our energy agency and politicians, and Margrethe Vestager from the European Union, all of them to discuss what is actually AI in the energy sector. How can we use this, and what do you think would be the next step? Because they're doing the legislation, and that's a big challenge because it can go different ways, all according to what kind of decisions they will make. But more than that, we would like to have the best engineering education throughout life, also continuing education. And all what we're doing are doing for to develop the technologies for sustainable change. And we would like to use the digitalization at any opportunity. So it's just the way we go. We have also some smart campus with a lot of data coming up in the sky. But maybe not as developed as at UC Davis, but at least we do have. And right now we have an autonomous or several autonomous buses driving around with no, they're just, it's small robots, you could say, a campus, and then you can just jump on and jump off. That's very, great to see. They're not that fast, so, but it's very nice. And then we also have this Skylab, which is we've got a lot of money for creating a hub where industry can meet students across all the departments, and they create the students love it, and I actually kind of look at PowerLab as Skylab just for energy sector, but Skylab is for any struggle that any industry might have. So they just meet and a lot of projects and also experiments and hand-on development will go on there. It's very popular by our students to have that. What we're working with, you mentioned Kristen, that we've been working together with you for many years, and now I just told you that there's 1,000 working within the energy field DTU, but in our area, we are around 100 working with the system. So we're not very deep into the wind technology or the solar panel technology. We are in the center of how to make all of this work together. So it's a system. It's also, it is both a transmission and also distribution, and also the connections to all the items out there. And then it's also the new digital energy solutions, and some of the technologies that are being a help for the system. And that could be to look into vehicle to grid, not only electric vehicles, but how do they give a service to the grid, back to the grid. So that's what we are working with, but that's what our lab has as a purpose. It's to test all of this in the system. And here's an overview of some of our labs in the lab. It's all named PowerLab. We have a high voltage lab. We can test, really make lightning and let them hit some different materials. Here you can see a blade on the floor. So when wind turbines get bigger and bigger, they get more lightning. So how to handle that? And here we have electric vehicle lab. We have a very huge RTDS for modeling and make simulations, both in real time and also by historic data. And I think also Kurt had been visiting some of our. It looks like a normal house, but it has so many sensors in that house. So it's a very you can test anything within housing, and how that could be also cooperating positively to the grid, changing between how to supply for electricity and for heat. Yeah, and then this is Bornholm, and we look at Bornholm as part of our lab. That's why it's here, and I'll come back with an example of what we can test and what we have been tested at Bornholm. But to have all this in a collection, that's very rare at one university. So it's a high requested university and lab to visit from all over Europe. Yes, yeah, for smart grid research and innovation. I have said that. So here is also another thing that you can do. We can take it from a small lab within a building at a university, test one battery, but we can put it out at the Risø, which is another location of our university, where we have a 5 kilometers power grid, and we are right now combining that with the district heating grid and a small gas out and intake. And then you can test things in a greater system, but still under the area of the university. You don't have legislations to take care of. And then when we get that to work, we can take it to Bornholm and test things with real people in a real utility, with a real utility that has to be work well in according to Danish laws and all the legislations.
Frida?
And yep.
We're gonna at 9:50 try to take some questions. So can we go for 2 or 3 more minutes? We have a lot of questions in the Q&A.
Oh, yeah.
So
Okay.
is that okay?
Yes.
Those 2 or 3 more minutes. I know you got a lot of stuff. I'm super interested in it. But
okay.
I have a couple, and actually some of them are controversial, so I'd like you to answer them.
Okay. Yes, of course. Should I jump to some others? I have those examples of Nordhavn I would like to show.
Yeah, maybe spend 2 or 3 more minutes, and then we'll wrap up and take some questions.
Okay.
Great.
So I'll just jump through some
Okay.
slides here.
Yep.
Sorry. Yes. Because and Bornholm, I've told you about what kind of examples we have here. Just want to mention spend my last 2 minutes on a project in Copenhagen, northern harbor area, because it's very expensive area and newly built, and we got this huge project and would like to develop with a lot of different both public partners and private partners how to make this in a new way. To show out how you can actually renew a totally new part of a city in a smart way. And all these red circles are new places that we tested new technologies across. And here we have the international school, and it's covered with solar PV facades, and we had some struggles to actually get them allowed to deliver electricity to the grid according to legislation. So we have found out a lot of what you call struggles for being part of to do stuff in a new way, and we actually constructed the way why we were having the project. Also, we spent a lot of effort in the district heating, how to make that a flexibility to the system. And we rolled this out after the project here for 7,000 residents in the area. So it actually got a huge important result, and also we then enables us to get it fossil fuel free in our district heating supply system for this area. Yeah, you can read that. There's a lot of conclusions. I think overall it's easy to do things in lab and in theory, but it's very hard to do it in real. And you get some also with the different partners to be able to. So we have this quad pro helix Energy Lab Nordhavn. We have the public authorities and city developer, and we had some utilities, and then we have the industry that would like to try out new technologies. And then DTU, who led the project, had all the data infrastructure. But to combine all these and then have the get to the officials and say, okay, you have some problem with your legislation. We would like to try this very fancy, sustainable things, and why can't we? And then we actually pushed the boundaries. And I think that's a very nice way to show how you can, as a university, be able to also push the boundaries and reach the goals. I think that will be my last things then. Yes, I would say more about next step for Denmark, but I'll stop here.
Thank you so much, Frida. Awesome presentation. I think that Nordhavn is in North Harbor or something, right? And I think I was there when they were building it. And so it's great to see that it's really happening. So I'm just going to roll into a few of the questions, and we have about 10 minutes left. And so one was that asking, I read that the last 10 to 20% of decarbonization are the most difficult and expensive. Is there any serious debate in Denmark about making the long-term goal only 90% or so?
I think no one is lower the ambitions, so that's for sure. But we have this discussion about how to do this in a smart way, and what would it cost. And then you have all the different sectors. I'm not saying screaming, but if you go to the power utilities, they would say this is the strategy for how to reach the goals. You should invest in our grid, in our ways to support our way of reaching the goals. But then you can look at another sector and they would say, we are the backbone, we are the important ones. But I have not heard anyone saying that we would lower our ambitions because it was too expensive. It's just how do we reach this in the best way? And I think everybody is aware that we need to collaborate between the sectors, and that our existing structure and way of that we have been doing for 50 years, where we have just been looking at electricity, the power sector for itself. We have been looking at the district heating as itself, and also had some laws and legislations around those sectors. We really need to unbundle all that and look at it across, and actually make new laws, new legislations. I think that is also why it's not that easy. But we're not lowering ambitions.
Right. Here's this one. There's so many great questions in here, and actually, hopefully, we can also address them offline. But how are you adjusting for sea level rise? I see new construction right on the water.
Sorry, I have to add that again.
Oh, hang on a second. It says, how are you adjusting for sea level rise? I see new construction right on the water. So they're seeing the Nordhavn right on the water. Are you taking into account?
Yeah, maybe that is a good question. I think they're also looking at floating wind turbines, and I think also these energy islands. The idea of that is maybe not for looking at the rise of the sea level, but it's for how to maintain and cost reduce, how to maintain and operate the wind turbines out at sea. I'm not into how actually they are thinking about preserving for sea level rise.
Okay.
So yeah.
And then there's a couple questions about storage. And that was, let me just grab this one. It says, is battery storage in utility scale or building base? And they also want to know what the average electricity rate for consumers see, and maybe how that raised or lowered as you guys transitioned. So it's 3 parts.
Oh, yeah.
So how do you use batteries? Is it building or utility scale? What's the rate that consumers pay? And did that go up or go down when you transitioned?
Yeah. The energy prices just went up in Europe, but other than that, it has been very low. But it just went up the last month here. Everything went up.
Battery storage?
What?
Are you using battery storage for utility scale or building?
Yeah. The battery storage. We are testing batteries bigger and bigger as at its own plant. Actually, right now we are trying a 1 megawatt battery at Bornholm. In their grid, it's a huge. You could say it's maybe it's not that big. It's a kind of a big plan for itself, and test that in the system and not in the system, and how can that be operating. At the Nordhavn also we had a battery at its own, where it was put in a parking lot in different levels, but at the ground there it was, and half of it was delivering service to the grid, and other half was the production and delivering service to how to fast speed powering cars. So this battery can be put up in it's not one unit. It's actually, you can part that in different units and use it different ways. But I think it's brand new testing that to look at them as a unit in the system, because other than that, it's been more in cars or smaller batteries supporting other things. Yeah. Great.
And then this one says, what is the current political climate in Denmark on atomkraft? And I think they mean nuclear power. They're asking about the spillover because of things like in Germany, there's a big opposition to it. So I know you mentioned that as part of your grid. Yeah. I don't think it's building new power plants, but can you comment on that, please?
On nuclear energy?
Yeah, it says, what's the current political climate in Denmark on nuclear energy? And
it's
German screen aversion.
It's not never going to happen.
But you mentioned it as part of the overall plan when you showed your slides.
Yeah. It's just to be, if you could look at that as a globally, I think when you look at how to transition your system, you should look at what is your existing systems and how far is that in your development, and how what kind of sources do you have. If you, for example, look at Germany, who has some nuclear power plants, should you just shut them down, or should you have a strategy for when it's worn out, then not reinvest, but do something else? I mean, I think you have to look at the whole system and go the way that every nation or region finds suitable for them. So that's why we can't be blind. It's there, and also we are importing sometimes some energy from nuclear power. For example, Christmas Eve, big day. I think every year there's a story that we will have some of our food made by nuclear energy from Sweden. So that's more a funny story, but it's out there, but it has not been part of our energy policy for, I think, 30, 40 years, and it will not be again either. It will never.
Yeah, thanks, Frida. I think that's a recognition on your part that there is a lot of nuclear energy in the system. So a couple more really good questions. One is from JJ Atala, and I'm not sure where he's writing from, but he says, I would like to raise a question about how we can adopt this amazing technology in developing countries, I guess from like Lebanon, where we lack power and we have outages because of economic crisis, with most people installing solar panels without any guidelines. So he just, I think, some guidance about a transition in developing countries. Anything?
I think it's very, very relevant, and I think what we can, there should not, it's a difficult question. I think we will look at some the electrification as some small islands, with distributed energy systems, and starting with the renewables and not starting the way that some of us has been doing, with all the black and coal. But still, there's a higher need for energy out there than there is put into generation right now, and I think that's a challenge. I don't have myself the answer to that, what to do, but I think the global society are putting also some funding and are also investing in energy infrastructure, those places. If you look at pension funds, for example, they have a lot of money and they would like to invest. And I think it's a very good investment to have that, because it also follows with industry and production and stuff like that. So I think there's money out there, but it's and there's a lot of companies looking for infrastructure projects, but to let people meet and to make it work. I mean, that's I have not the full overview of that, but I recognize it's a very important question.
Thanks a lot, Frida. And JJ, maybe offline you can talk to my group, because we work sometimes with these kind of issues in my D Lab. So it's great to hear from you. I put on your technology hat for a minute, Frida. Has there been any reports of stray electricity from buildings covered with solar panels affecting occupants? So they're asking, is there any stray electricity coming off these solar? They see these big structures of solar panels. Are people in any danger from stray electricity?
Any danger?
Yeah, is there any stray, I guess, IMF or anything else coming from these big arrays? Any idea?
I have not heard of it. Actually, not the very, not in public. I think some, the big transmission lines, some are that influencing your something well-being, and also some has on onshore wind turbines. We do have some discussions. They like wind turbines in Denmark, but not in my backyard. So I mean, and some are this small noise. Would that affect me taking 1 or 2 years of my lifetime because of that? There's some people have this discussion, but then you can say, if you look at your phone and you have that to your ear, very close to your brain, I mean, is that a bigger impact or lesser impact? I don't know. It pops up sometimes, but I think mostly Danes are proud of the wind turbines and think they're beautiful, but still not in my backyard. I think that covers a lot of people.
We have one more. I think we have one. And oh, by the way, how much is it per kilowatt hour electricity in Denmark? The actual right now, after they raised your prices.
Yeah, do I know? I think 2 to 3 Danish kroners per kilowatt. It's not that much that people actually are looking at that bill, and that's often not the purpose for making some energy reduction. Not for the electricity. For the heating, yes, that gives more an impact. For you can actually halve your reduction if you isolate your house better and use a heat pump instead of a traditional fuel. But it. Yeah, and now I don't think it's not a big chunk of our household economy.